Hi, my name is Jaden. This is my individual project for our Intro to Engineering, the ProRover, the automated tennis ball collection robot. The problem: time is wasted collecting tennis balls. Now, many tennis players go out to the tennis court and they just want to hit balls. Now, after the tennis players are done hitting their balls or they run out of balls, it comes to the tedious task of collecting them. Now, this is a very time-consuming task, seeing that not many products on the market are available for this, and most of the time you just get caught picking them up hand by hand. There's no really autonomous way about collecting tennis balls, so this is where the problem really lies, that time is wasted for tennis players because they just want to go out, have fun, play the game, but instead they are wasting time having to collect and get tennis balls. The solution. My solution for this problem is the ProRover, the automated tennis ball collector. Now, pictured here, we will see kind of a mock drawing for what I'm envisioning for this project that I'll just run through. And I'll also be going through more components of this design in the future slides. Now, we see here that we kind of have a little box and a little rolling cage that follows it. The idea here is that the tennis balls will roll under this box and directly into that cage, where the balls will be squished and roll with the cage as kind of like a little storage container. Now, in the incoming slides, I'll explain kind of how these components work together and how the ProRover roams around the court and collects balls. Ball collection. Now, I started to get into this in the previous slide, but there are a few more things that I'd like to add here, mainly with the outer shell. Now, if we look in the bottom right, we will see the inventor drawing for this outer shell, and in the shell, which I'm going to talk about here, we will add the battery and the computer components for our robot. The computer will, which I will get into next slide actually, will control the motion and how the rover roams around the tennis court. And the battery will obviously power the wheels so it rolls around and supply power to the computer components and make sure everything runs smoothly. And then getting into the storage shell, which was basically explained in the last slide, as the robot, or like the robot shell, rolls over tennis balls, the balls will roll into the storage roller here, which then, as the robot rolls around, the storage roller will collect tennis balls. And another thing to note here, for ease of transportation, we are going to make it so that the storage roller and the outer shell are detachable from each other. Now, this will also be good, so if you say one of the storage rollers is already full, you can just detach one of the storage rollers and put a new one on, or empty it out and put it back on the robot. And mainly, yes, so that's how the ball collection is done, and kind of how the robot shell will work as a storage container for the battery and computer components. Moving on to the computer components. Now, at this point, you may be wondering, well, how does the rover know where it's going? How does it know to stay out of the court or wherever it will be? Now, the approach to this was kind of out of two options. One was to make it kind of like the Roomba vacuum, where it kind of just knows where the court is and where it's going. But that requires us to also know where the court is, what kind of the court is itself. Now, not every court or tennis court is the same size, so making that computer part would be, I think, a little difficult. And I think an easier way to go about this is to use directional cones. Now, directional cones will act almost as a wall for the robot. So say the robot is moving in towards the tennis court, but we have a directional cone set up around the tennis court itself. Now, once the rover runs into that line that is right next to the tennis court, it will turn around and go back to collecting balls. And also noted, if the rover runs into the fence or the pole on the tennis court, we have a bumper detection system that will allow the rover to just turn around and go about its business. So the directional cones and the bumper detection allow for it to kind of stay out of where you don't want it to be, or stay in a designated area. And it is also important to note that these directional cones and the rover itself is battery operated. I know I mentioned that the rover was battery operated in the last slide, but I just thought, we should put this in here just so it is certain and it's known. Why the ProRover? Looking at this, there's only one other competitor on the market that has an automated tennis ball collection system. But that system is a little over $2,000, which can be costly for some people. And some people just aren't willing to spend that for a tennis collection robot. Now, what I believe we have over this competitor and what we can improve on is that we can make this ProRover more transportable and more inexpensive. And I believe we can do this because we have the transportation for, we can disconnect that storage container and the robot itself. So already we have that transportable effect. Now for inexpensive, looking at our design, we only have like 4 or 5 major components. One being that outer shell, the second being the storage roller, which both of those will probably most likely be either made out of plastic or a cheap metal. And moving after that, we have the battery and computer components, which will add up a little bit of price, but overall, I don't think that'll drive up our price too marginally. And lastly is our directional cones, which also is just a little computer hardware components, which I don't think will add up the price to the tennis rover or the ProRover to be too expensive. Now, overall, I think having those components over the other competitor gives us a big run for our money for why we should go for the ProRover. Ending thoughts. So we've went over the design, the components, and why we believe that this ProRover is better than what other competitors have, and why we should go ahead and engineer it. Just touching on some of those real quick again, just a little recap. The ProRover works by driving over tennis balls and rolling them and collecting them in the storage unit. The directional cones keep the ProRover from going either into the tennis court, or it keeps it in a locked area. And if the ProRover runs into a wall, we have that bumper detection system, so it will go ahead and turn itself around. And we believe it's better than the competitors or the single competitor because we can go ahead and we believe we can make it cheaper than what other competitors have. And I believe that we have a good design here and something that can possibly go ahead and work. So with those thoughts, I think we're good to end it off. And I hope you enjoyed my presentation on the ProRover, the autonomous tennis ball collection robot.